So now that we know about polarity, we got to figure out where we should place the program 0. Why do we place program 0 in specific spots? Is it just because it's a needle in a haystack and you're just guessing? Or is there reasoning behind it? Well, there's obviously reasoning behind it. We're going to go over reasons why you would do it based on the part print and based on how parts are mounted in a vise. So to start out with, we're going to look at an example part here, and we see that this part is dimensioned off of the lower left-hand corner. So if we were going to look at this and say, well, where do I want to make my program 0? We're looking at this as a programmer and not as a setup person or anything like that. You will have to figure it out through a setup person's eyes later on. But for the most part, this part is all dimensioned off the lower left corner. You'll see the 0, 0 is down here. And that's how it is on the print. So it would just be easiest as a programmer to make this right here 0, 0. So you'll see our datum surface or our program 0 would be off this corner. That way when we're finding our x, y location, it's easy enough to say, oh, 0.5 in the x, 0.5 in the y. And so on and so forth. You have 0.5 in the x, 3 inches in the y. Now if you did it off of up here, you'd have to do some math. You'd have to say, well, this is 3.5 inches tall, so I'd go 3 inches up. So if this is 0, I'd have to say, well, I'm going down 1/2 inch in the y. It would be negative, but you really don't know that because they don't give you a full dimension up here. So the easiest point would be right here. This way, our first point would be 0.5, 0.5, both positive. 0.2 would be 0.5 by 3 inches. Center point would be 2 1/4 by 1.75. So you can see here and here. And so on and so forth throughout the part here. Now this part doesn't have all our dimensions off of an ordinate over here. You'll see that there's no datum surface being dimensioned from, so there's no one surface everything's coming off of. So you're going to have to look at it and say, well, where are most of my dimensions coming off of? Now in this case, these dimensions here, this one, and this one, all come off this side. So we know we're going to use this side for 0. And then this dimension coming down is from this top. This dimension coming down to here is from the top. But this dimension right here is actually coming off of a previous dimension that was from the top. So the smartest place to put the origin would be this upper corner here. So we're going to put our origin right here. And our holes would then be 0.5 over by negative 0.2. Now you get negative 0.2 in the y by doing some math. You got 1.5 and 0.5. So I had to come down 0.5, another 1.5. I get 2 inches down. Up to the top here, I'm down 0.5 in the y. I'm over 0.5 in the x. And then we'd look at the parts here. Notice how my y's are all going to be negative through the part. So in this case, all my x's are going to be positive, all my y's are going to be negative. So how about for round parts? Well, I would say almost always for round parts, it's just way easier to use the center location as your origin. Now you could take a theoretical point as though this line came out here, and I'll show you a little picture, or try to. If I were to take and say, draw a line out and draw a line up, I could get a theoretical point there. So I could have a theoretical point right here that I could use. Now that isn't necessarily the best, it's just way easier to go right off the center here. So what we're going to do is choose the center for any of our round parts. Here's a part that's a little bit different. We're going to assume that this is some sort of casting or something that's already been machined, and it doesn't have corners here. So those have already been removed in a previous process. We have to put these two holes in it. You'll see some of our dimensions coming off this bottom side over here. We know it's 3 inches by 3 inches. It's also coming off of up here. So in reality, we could use a couple different locations for 0. We could use this point up here or this point down there. So it's really up to you where you'd want to use it. However, we need to somehow seat this part on a machine. Now, if we were putting it in a vise, you could just pinch between here and you could probably put it in either location. But you sometimes have to think about how this is going to be held down. If you're going to hold this down with clamps of some sort, you'd want to look at where am I going to put stops or locators to keep this thing straight. For instance, we may have a locator here, a locator there, and a locator there to get this in here. Well, if that's the case, these locators are going to be your ordinate then. So this upper left corner would be your 0. Now if you'd have those locators down here, that would be your 0. We're going to say they're up in this location. So this is going to be our origin or our program 0. But when you do this, you got to make sure your part's the right size. If it's not 3 by 3, if it's measuring a little bit over, then you're going to have to change your mindset on how you're going to do this. You may have to do it in 2 setups. One setup to come in by ½ inch by ½ inch, and then set another 0 to do this other hole. So we drill our holes, ½ inch by ½ inch, and then you come over to this one. Now in this case we have to do some math. We know this is 3 inches over, so we have to come back ½ inch to get to this hole. So it's 3 inches minus ½ gives us 2.5 in the X. And in the Y, you're going to go 3 inches down minus ½ inch, gives us 2.5 here. Now, by looking at this slide, I guess I've never noticed it before, but if this is my origin and I'm moving to this side, that's definitely a positive motion. Right here it's showing us negative. That's definitely a mistake in the slide. So if you are noticing that, if that's confusing you, it's confusing me too, but that should be a positive motion here. Alright, so that's for the X and Y. Now how about the Z? So if we look at our parts, this is the front view in a vise. We have to locate our part in the Z as well, not just the XY. I usually like to always go off the top of the part, it's just a lot easier. Or maybe I'll do a dimension off of the bottom, but I always try to have it off the top. I'm not going to try to touch my tools off on the bottom and make that 0. It just makes it a lot harder to program, and I'll show you why. So if the top of our part is Z0, which most programmers prefer, as it says here, everything into our material is going to be a negative value. So all your program numbers when machining will be negative. So for instance, I bring a drill down. I'm 100 thousandths above my part. I can always use 100 thousandths for clearance because I know I'll miss my part. I have to go down ½ inch from my program origin, plus maybe I drill through the part a little bit. So I bring my drill down to negative 0.6 to get through our part. It's a negative number. It's easy math because really all I'm doing is telling the thickness of my part plus what I want it to break through. Now if you were to do this and have the bottom of your part be 0, some people do that, I just think it's a lot harder. So for instance, same situation, this is a ½ inch thick. I bring my tool down to 100 above my part. Well, 100 above my part, I have to figure it out from the bottom, so I have to say, well, it's really a ½ inch above my part, plus 100 above my part, and now my rapid plane is always going to be 0.6 above my part. When I drill into it, I bring it down to 0, because this is the bottom of my part would be 0, and then I have to go an additional 100 thousandths. So I'm telling it to go negative 0.1 to get below the part. To me, this is just confusing. It's a lot harder to figure out. So I would recommend going off the top of the part. Here's another example. This is a step block. So we have 3 steps cut out of this. And we're going to drill a hole here, drill a hole here, and drill a hole here. So if we're going off the top of our part, this first hole is going to be a ½ inch deep. My second hole is going to be 1 inch deep because I'm going a ½ inch plus a ½ inch. And my third hole is going to be 1 1/4, or I guess 1 1/8 plus a ½ inch. So it's going to be 1.625 to the bottom of that one. So my origin's up here. Bring my tool over to 0.1, nice and easy to remember. Drill down ½ inch deep. I'm at the bottom of this hole. I'm now going to move my tool back up to point 1, and then I'm going to move it over to here, and then notice how it's still at Z.1, drill down into my hole. But I don't want to drill all the way from the top. If I drill all the way from the top, I'm going to be going slow through this motion here and wasting time. I can really wrap it down to here and then drill slower right here. So what I do is I tell it, okay, go down to -0.4. And then I'm going to drill from there. I go to -0.4 because I'm a ½ inch below the top of my part, but I want to start at 100 thousandths above that. So if I take 0.5 down to get to here, I then move up 100 thousandths, and then in that case I'm -0.4. And then I'm going to drill into my part to -1 inch. Now I'm just assuming that each one of these holes is going a ½ inch deep from the plane. It doesn't really show me that here, but that's my guess. Now I could wrap it all the way back up to point 1, but I don't really have to. I could just wrap it 100 thousandths above this plane and then move over and not waste extra time to go up and over. Wrap it over to here. Now I'm going to wrap it down to 100 above this plane, so that would be -1.025. So right here, -1.025. And then I'm going to drill into my part, -1.625. And I get down to there. Now in this case, I could wrap it up to right here, but I'm also done drilling, so I'm probably just going to wrap it up to point 1. In this case, I did wrap it up to here, and then I would wrap it up a little bit further. So the next lesson we're going to do is absolute versus incremental modes, but we'll talk about that in the next video.